So this is my chapter 8 exam, and the question I had to do was question 5. And 5A says a system composed of the following particles: a 0.5 kilogram particle at the origin, a 1.25 kilogram particle at x equals 0, and then at x equals 0 0.15 meters, and then y equals 0.2 meters, and at 0.775 kilograms particle at x equals 0.2 meters, and then y equals negative 0.8 meters. Find the x coordinate of the center of the mass of the system. So the formula I would have to do would be x cm equals m1 x1 plus m2 x2 plus m3 x3, and then the bottom will be m1 plus m2 plus m3. And then I'm going to plug in the numbers. So I'm just going to do xcm equals 0.5 times 0 plus 1.25, so you can see, times 0.15 plus 0.75 times 0.20 over parentheses 0.5 plus 0.75 plus 0.125. Oops. And then you get, for the x cm equals 0.135 meters from origin. That's part A. And then part B says find the y coordinate of the center mass of the system. So to find the y coordinate, I would just, well, here's the answer. And to find the y coordinate, I would just do the same thing. So I would just use this formula, but I would just put y instead. So it would be m1 y1 plus m2 y2 plus m3 y3, and then m1 plus m2 plus m3. So then I'm gonna, like how I did here, I'm gonna place those numbers back in here, but for the y. So I'm just gonna put on this side. So I have 0.5 times 0 plus 1.25 times 0.2 minus 0.75 times 0.80. Sorry, I had to squeeze that in right there. And then over 0.5 plus 0.75 plus 1.25. And then you get, for the YCM, you get equals negative 0.14 below origin. And like that, so you can see. And then for 5C, let me read it. It says 3 objects lie along the x-axis. A 3 kilogram object is at origin. A 2 kilogram object is at x equals 1.5 meters, and a 1.2 kilogram object is at an unknown position. The center of mass of the system of 3 objects is at x equals negative 0.2 meters. What is the position of the 1.20 kilograms object? So I'm gonna say I'm gonna position 1.2 kilograms as x, and then I'm gonna do this formula again, and I'm gonna just write it out again. So 1.2 is gonna be the x. So M1 plus x. M1 x1 plus M2 x2 plus M3 x3, and then M1 plus M2 plus M3 right here. And then I'm gonna write down the numbers so you know like which ones go into which. So M1 equals 3 kilograms, and then x equals 0, and then for M2 equals 2 kilograms, and then x equals 1.5, M3 equals 1.2 kilograms, and x equals x. So then I plug in now, and then I'm gonna use I gotta plug in also negative 0.2. So, but I'm gonna plug that outside the fraction right here. So I'm gonna do negative 0.2 equals, because that's what's given to us. All these are also given, equals 3 times 0 plus 2 times 1.5 plus 1.2 x over 3 plus 2 plus 1.2. Then once you do all that, you get equals, you do 6 times 2 times negative 0.2, which equals, you would do 0 plus 3 plus 1.2. Then you would get equals negative 1.24, which equals 3 plus 1.2x. And then now you would just do like the regular math. You would bring 3 over to here, subtract it, and then you divide the 1.2x. And then you would just get, and now equals negative 3.53 meters for x. And then for 5D, it says you hold a 0.25 kilogram glider A and a 0.5 glider B at rest on an air track with a compressed spring of negligible mass between them. When you release the gliders, the spring pushes them apart, that they move in opposite directions. When glider A has moved 0.96 meters to the left from its starting position, how far to the right from its starting position has glider B moved? So I'm gonna do, I know MA, because glider, I'm just put glider A, but I'm putting it as M equals 0.125. Right here's also like that, and then M glider B equals 0.5. Put the units, and the center of the mass is like constrained, or don't know, like constrained, I guess. So then I would do this formula. I would just do this formula again, but like a little bit different. So you would do MA, like a triangle, times XA plus MB, the triangle again, XB. So now you now to break down the fraction, you do 0 equals MA equals the triangle, MA triangle XA. I don't know, I did another triangle, but make it an A, plus MB triangle XB. And now to break it down, you would get, I'll just write it on this side to save room so you can see how I'm doing. This is the formula, and now we're just breaking it down. All I did right now is add 0, but now I'm gonna break it down more. So now let's do equals M A triangle XA equals negative MB triangle XB. So now I'm gonna plug in the numbers. MA is 125. So I'm gonna put 0.125 times 0.96 equals negative 0.5 parentheses triangle XB. After doing all the math, you would get 0.24 meters as the answer for how far the glider B moved. And then for 5E, it says these three objects each have mass M. Each object feels a force from the other two, but not any other object. Initially, the first object is at X equals negative L. X equals negative L. Y equals 0. The second object is at X equals plus L. Y equals 0. And the third object is at X equals 0. Y equals L. The momentum of the system of the particles at the initial time is 0. At a later time, the first object is at X equals negative L over 3. Y equals L over 4. And the second object is at plus L over 2, and Y equals negative L. At this later time, where's the third object? Find the X position of the third object. And then also part F says find the Y position of the third object, because I'm going to put them both together. A work, so I'm going to flip over. So first, I'm just do the work for 7E, and then I know no external force is available, so the position will not change. So center mass will equal the initial position, and then the other center mass will equal the final. So what I would do would be L, J. I'm just gonna use like L and I just to help like separate them as like the X and Y. Like the X's and the Y's are gonna have like I's and J's. And that's probably what I'm gonna use. So then I'm gonna have LJ equals negative L over 3I plus L over 4 plus L over 2I minus LJ plus XI YI or YJ. Excuse me. And then LJ plus L3 I, so you can see minus L4 J minus L2 I plus L J equals XI plus YI or YJ, I'm sorry. So now I'm gonna have LJ plus LJ minus L4J plus L3I minus L over 2I equals XI plus YJ. And then now I'm gonna combine these two. So just get 2LJ minus L4J plus L3I minus L2I, which equals XI plus YJ. And then now, I'm gonna combine everything. So now you gotta have a common denominator. So this already has 4. So now I have to put 4 on the bottom. So I'm gonna do 4, put 4 here and times by 4. So you would get 8. So you can see I added 4 here because you have to have a common denominator, and which is 4. And then now I have to do 4 times 2 to get 8. So you have 8LJ minus L over 4 plus, and you have to have a common denominator here for the Li, the L over 3I minus the L over 2I, and which is 6. So you just multiply them. I just combine them to make 6. So I would do 2Li minus 3Li over 6. Because 3 times 2, 6. 2 times 1 is 2, and 2 times 3 is 6. And then 3 times 1 is 3. So that's why we have the 2 and 3. Because you have to find the common denominator for the 2. And then you just combine them after. And then equals XI plus YJ. And then now you do the math and subtract them. So you get 7LJ over 4 minus Li over 6, because these two cancel, the 2 and the 3 cancel out. 2 minus 3 is -1, so you just put it back as Li. And then equals XI plus YJ. So the I's meant X. So the I component, oh, no, I spelled component wrong, sorry. Equals -1 L over 6. And then the J is Y. So then the J equals the J component. We'll say X equals I and the Y equals J. And that equals 7L over 4. And then as you look here, it's the answers I got. It's minus L6, and then Y equals 7L over 4.